Hello everyone, welcome to my YouTube channel. Today I will solve some questions related to the inverse Laplace transformation. Let us start with my first question, which is basically based on the first shifting formula. So we know that the Laplace of ft is fs. So our inverse transformation of fs will be ft. So in this chapter or in this lecture, I will find out this ft. So starting with the question number 1, evaluate the Laplace inverse of s plus 3 upon s square plus 2s plus 2. So our solution is the denominator can be written as s plus 1 whole square plus 1. This is your a plus b whole square plus 1. Now we will try to convert this s plus 3 in terms of s plus 1 so that we can use the first shifting formula. So this is equal to Laplace inverse s plus 1 upon s plus 1 whole square plus 1 plus 2 times the Laplace inverse of 2 upon s plus 1 whole square plus 1. Now we can use the shifting formula. Now as we have s plus 1 in place of s, so we can use the first shifting formula by which we will have e to the power minus t, and then in the bracket we will have s upon s square plus 1, and here in place of s we have s plus 1, so we will have e to the power minus t outside. Then in the bracket, I think this one here will be 1, so in the bracket we will have s square plus 1. Here we have used this formula, Laplace inverse of, as we have Laplace of e to the power at ft equal to f of s minus a, or e to the power minus at equal to f of s plus a. So the Laplace inverse of f s plus a is equal to e to the power minus at ft. So we have used this formula. In our case, our a is 1. So now this is your Laplace of cos t. So we will write it as cos t. Then here we will have 2 e to the power minus t, and this is your sin t. So this will be your answer. Then let us solve another question which is based on second shifting formula. What is the value of this particular function? Laplace inverse of this function. Now we can write it as Laplace inverse e to the power minus pi s upon s square plus 1 can be written as Laplace inverse e to the power minus pi s, and this can be written as cos t. We can write it as fs, where my fs is s upon s square plus 1, and whose inverse Laplace is cos t. So the inverse of this fs will be ft, and here the inverse of s upon s square plus 1 is cos t. Okay. Now we have the formula of second shifting formula, which says that the value of this one is ft minus a ut minus a. Now in place of a we have pi, so this will be your ft minus pi ut minus pi, and ft is cos t. So this will be your cos t minus pi ut minus pi, because the Laplace of ft minus a ut minus a was e to the power minus a as fs. So due to this second shifting formula, our answer is cos t minus pi into ut minus pi. Then again third question is based on this second shifting formula. Evaluate Laplace inverse e power minus 3s upon s into our s square plus 4. Solution. Again, the Laplace inverse of e power minus 3s 1 upon s square plus 4 can be written as Laplace inverse e power minus 3s into fs, where our fs will be 1 upon s square plus 4. Now on partial fraction we will get 1 upon s minus s square plus 4 into s divided by 1/4. This is the partial fraction of this one. The partial fraction of this one will be 1 upon s minus s upon s square plus 4. You can write it as a upon s plus bs plus c upon s square plus 4. So on evaluating the value of a, b, c, we will have this result. Now again, due to the second shifting formula, this will be your ft minus a. Now in place of a we have 3. So this is your ft minus 3, ut minus 3, where my ft is this one. Now this was my fs. Now my ft will be the inverse of this one, which is the inverse transform of 1 by s was 1, and the inverse of s upon s square plus 4 was cos 2t. So in place of f we will have to replace this function. So our answer will be 1 by 4 1 minus cos 2. Now here I have t minus 3, so our t will be replaced by t minus 3. So this will be t minus 3 into ut minus 3. This is your answer. Again, we know that ut minus 3 has two values, either 1 or 0. So we can also write it as ut minus 3 has value 1 if t is greater than 3. So our answer will be 1 whenever your t is greater than 3 or equal to 3, and it will be 0 when t is less than 3. So this will be your answer. This is your answer. Then coming to the next question. Here we have a formula. Note that as Laplace of t ft is equal to minus d by ds of fs. So from here we can write the Laplace inverse of d by ds of fs. The Laplace inverse of d by ds of fs equal to minus t ft, and this can also be written as minus t, and ft can be written as Laplace inverse of fs. So we have a formula that the Laplace inverse of fs is equal to minus 1 upon t, the Laplace inverse of d by ds of fs. So the Laplace inverse of fs is same as minus 1 by t, the Laplace inverse of d by ds of fs. Now what is the importance of this formula? It can happen that you are not able to find out the Laplace inverse of some function, but it is possible to find out its derivative Laplace inverse. So whenever we find some complex functions such as trigonometric function where we do not have any direct formula, we will use this particular formula. For example, evaluate Laplace inverse tan inverse of 1 by s. Here we do not have any direct formula, so we will try to apply this particular formula. Solution. The Laplace inverse of tan inverse of 1 by s will be equal to minus 1 by t. The Laplace inverse, use this formula, the Laplace inverse d by ds of this fs. that means the tan inverse s, tan inverse 1 by s, and this is equal to minus 1 by t, the Laplace inverse of derivative of tan inverse 1 by s, which is equal to 1 plus 1 upon x square, 1 upon 1 plus x square. Now here in place of x we have 1 by s, then again the derivative of 1 by s, it is equal to minus 1 upon s square. So this is equal to minus 1 by t, the Laplace inverse. Now this minus and this minus will be plus, and here we will have 1 upon s square plus 1, and this is your sin t. So our answer will be sin t upon t. So the Laplace inverse of tan inverse 1 by s is sin t upon t. Then again let us find out the Laplace inverse of log 1 minus 1 upon s square. Solution: using the same formula we can write it as minus 1 by t Laplace inverse d by ds of log, let us take LCM, s square minus 1 upon s square. So before differentiation, apply the formula of log a upon b, that is log a minus log b, and this will be your, the differentiation of log x is 1 by x, and then differentiation of s square will be 2s. So 2s upon s square minus 1. Here we will have 2 log s, that means 2 by s. Now the inverse Laplace transformation of s upon s square minus 1 is your cos hyperbolic t, and the Laplace inverse of 1 by s is 1. So your answer is 2. In the bracket we will have 1 minus cos hyperbolic t divided by t. This is your answer. Now I have 3 questions which are related to each other, and we will solve them using the different formulae. Let us start with the question evaluate. In the first question, s upon s square plus a square whole square. Second question is evaluate 1 Laplace inverse of 1 upon s square plus a square whole square. And third question is the Laplace inverse of s square upon s square plus a square whole square. We can also evaluate their Laplace inverse using the convolution theorem. But right now I will evaluate these inverses through the definition. Let us start with the question number 1. Using the previous formula, which was your this one, put fs as 1 upon s square plus a square. Put fs as 1 upon s square plus a square. So this will be your Laplace inverse 1 upon s square plus a square is equal to minus 1 upon t, the Laplace inverse of d by ds of fs, where fs is 1 upon s square plus a square. Then this can be written as minus 1 by t, the Laplace inverse of the derivative, and differentiation of 1 upon x is minus 1 upon x square, and then differentiation of this s square will be 2s. So this will be a minus 2s upon s square plus a square whole square. So this is the right hand side, and this implies now the left hand side. In the left hand side, this is the Laplace inverse of sin 80 upon a. So the left hand side will be 1 upon a sin 80, and the right hand side is 2 upon t Laplace inverse of s upon s square plus a square whole square. So our answer is the Laplace inverse of s upon s square plus a square whole square will be t upon 2a sine 80. So this is your answer. Now let us start with the question number 2. In 2, we will use some other formula. This can be written as the Laplace inverse of 1 by s into s upon s square plus a square whole square. We can write it as this one. Now let us assume this one as fs, where my fs was s upon s square plus a square. Now by first part its inverse transform was t upon 2a sine 80. Now we have the formula for Laplace inverse of fs upon s, which was integral 0 to t fu, or you can say ft dt. Now using this formula, our answer will be 1 by 2a integral 0 to t sine 80 dt. Now we will integrate this equation using the chain rule, which is t integration of sine 80 will be minus cos 80 upon a, then we will have minus sine, then the derivative of t, which is 1, then again the integration of this bracket, and that means the integration of cos 80, that is again minus sine 80 upon a, so we will have a square. Then the limits are from 0 to t. Now you can see that both lower limits are 0, so we have upper limit as, here we will have upper limit as t cos 80 upon a, and here we will have upper limit as sine 80 upon a square. So our answer is 1 upon 2a cube sine 80 minus 80 cos 80. So this is your answer. So let us start with the question number 3, which was Laplace inverse of s square upon s square plus a square whole square. We can write it as Laplace inverse of s into fs, where my fs is s upon s square plus a square whole square. So again we have inverse Laplace transform for this fs. Now we can use the Laplace inverse of sfs. Please remember that Laplace of f dash t was sfs minus f0. So on taking the inverse transformation, we will get the Laplace inverse of sfs minus the Laplace inverse of f0. As f0 is constant, so we will have so we can take f0 outside. Then in the bracket we will have Laplace inverse of 1, and Laplace inverse of 1 was delta t, that means Dirac delta function. So we have the formula, the Laplace inverse of sfs is equal to d by dt of ft plus f0 delta t. Now we will use this formula. So using this formula, our Laplace inverse sfs will be d by dt of ft plus f0 delta t, where ft means the inverse of fs, and the inverse of fs was calculated in first part, which was t upon 2a sine 80. So you can see that our f0 will be 0, so our answer will be the derivative of ft. And now the derivative of ft will be d by dt of t upon 2a sine 80, which is our answer, and we can write it as sine 80, differentiation of t will be 1 sin 80, and then differentiation of sin 80 will be a times cos 80. So this is your answer. So these are three important questions. The Laplace evaluate the Laplace inverse of s plus 1 upon s square plus 2s plus 2 whole square. We have to evaluate its Laplace inverse. Solution, we can write it as s plus 1 whole square plus 1 whole square. This term can be written as s plus 1 whole square plus 1. Now again you can see that in place of s we have s plus 1. So due to shifting property we can have e to the power minus t outside, and now in the bracket we will have s square plus 1 whole square, and this was your, see the first question, this was your t upon 2a sin 80. Now in place of a we have 1, so this will be your t upon 2 sin 80 means sin t. So this is your answer. Now I will solve some questions related to the partial fraction. So let us start with the question. Evaluate the Laplace inverse of 4s plus 5 divided by s plus 2 s minus 1 whole square. Let us find out its Laplace inverse. So using the partial fraction, this term can be written as a upon s plus 2 plus b upon s minus 1 plus c upon s minus 1 whole square. So this can be written as a s minus 1 whole square plus b s plus 2 s minus 1 plus c s plus 2 is equal to 4s plus 5. So let us put s equal to 1. So if s equal to 1, then we will have c into 3, then 3c equal to 9, that means c is 3. If s equal to minus 2, then this will be your 0, and again there it is 0. So here we will have 9a is equal to minus 8 plus 5, that means minus 3. So our a will be minus 1 by 3. Now let us compare equating coefficients of s square on both sides. Let us equate the coefficient of s square on both sides. So on computing the coefficient of s square, here we will have a, from here we will have b, and in the right hand side there is no coefficient of s square, so this will be a 0. So b will be minus a, and that will be a 1 by 3. So finally we can say that the Laplace inverse of 4s plus 5 upon s plus 2 s minus 1 whole square is equal to a upon s plus 2, that means minus 1 by 3 Laplace inverse of 1 upon s plus 2, then b upon s minus 1, that means 1 by 3 the Laplace inverse of 1 upon s minus 1, then c upon s minus 1 whole square, that means 3 Laplace inverse 1 upon s minus 1 whole square. Now due to the first shifting formula, the Laplace inverse of 1 upon s plus a is e to the power minus 2t. So this will be e to the power minus 2t, and here we will have e to the power t, and here you can see that in place of s we have s minus 1, so we will get e to the power t, and then the Laplace inverse of 1 upon s square is t. So this will be your answer. So this is your answer. Now let us start with the next question. question is, evaluate the Laplace inverse of s upon s power 4 plus s square plus 1. Let us compute its Laplace inverse. Solution. Here we can write s power 4 plus s square plus 1 as s square plus 1 whole square minus s square. A square minus b square can be written as a. If you open the bracket, then you will get s power 4 plus 1 plus 2s square minus s square. So we will get this term. Now a square minus b square will be a plus b and then a minus b. So this will be your a plus b and then a minus b. So this is the fraction. Now we will use the partial fraction, which can be done very easily. So this will be your 1 minus s minus 1 upon s square plus 1 plus s. This can be guessed very easily, because if you take Sm, then in the numerator we will have 2s, and as we have s, so we can divide it by 2. So this is our inverse. This is our partial fraction. Again, this can be written as, now try to make it perfect square. So we can write it as s minus half square. Then we will have 1 by 4. 1 minus 1 by 4, that will be 1 minus 1 by 4, that will be 3 by 4. We can write it as root 3 upon 2 whole square. Here we can write it as s plus half whole square, again root 3 by 2 whole square. And this is equal to, now you can see that in place of s we have s minus a. So this is equal to e power t by 2. Then we will have Laplace inverse s square plus root 3 by 2 whole square minus e power minus t by 2, the Laplace inverse of s square plus root 3 upon 2 whole square. Now the Laplace inverse of 1 upon s square plus a square is equal to 1 upon a. So this will be 1 upon a sin 80. And here we will have 1 upon sin 80 upon 1 by a. So root 3 by 2 is common. So we can take this 2 by root 3 common, and sin root 3 by 2 t is again common. Then in the bracket we will have t e to power t by 2. Here we will have e to power minus t by 2. Then this 2 can be taken inside. Now this is your e to power x minus e to power minus x divided by 2 is your sin hyperbolic t by 2. So this is your answer. Yes, this is our answer. So now let us start with another question. We have evaluate the Laplace inverse of s upon s power 4 for a power 4. Solution. Now this term can be written as s upon s square plus 2a square whole square. Now let us open this bracket. This will be your a square plus b square plus 4a square s square. So we will have to subtract that term. So 4a square s square, that means 2a whole square. So a square plus b square plus 2ab, that means 4a square s square. Now this is your 4a square s square. Now again, this is your a square minus b square. That will be your a plus b and a minus b. So again do the partial fraction, and after the partial fraction we will have 1 by 2a, and partial fraction is not a tough task, so you can easily guess the partial fraction, which will be your this one. You can also cross check it by taking the LCM. If you take LCM, then at this place you will have 2a's, and here you will have plus 2a's. So we will have to divide this one by 4a. So here we have 1 by 4a. So this is the partial fraction. Now again, using the same technique of the last problem, we can try to make the denominator perfect square. So we can write it as s minus a square plus a square, because this will be your a square plus b square minus 2ab. Similarly, here we will have s plus a square plus a square. So this is your 1 by 4a e to power at, the Laplace inverse of 1 upon s square plus a square. At this point we will have e to power minus at, the Laplace inverse of 1 upon s square plus a square. And this is your 1 by 4a e to power at, this is your sin 80 upon a, and here we will have e to power minus 80 sin 80 upon a. So we can take sin 80 upon a common. So 1 upon 2a sin 80, and in the bracket we will have e to power 80 minus e to power minus 80 divided by 2. We have taken 1 2 here. Now this is your again sin hyperbolic 80. So this is your answer. Yes. Here is a mistake. This a will come outside, so this will be your a square. So this is all about the partial lecture.